Good morning, everybody. My name is Ryan Hutchinson. I'm an employee of SpotRF. I've been with the company about a year and a half now. They brought me on in April 2019 after I had previously been installing the product for a security integrator in Calgary, Alberta for 5 years. And then before that, I was a technician for 2 years installing access control CCTV intrusion systems all over southern Alberta. And before that, I was a locksmith. So it was interesting how my security background has changed through the years. And I hope you guys enjoy this presentation. So what was the purpose of SpotRF? Purpose was to provide a product that would be able to protect critical infrastructure, increase awareness, save lives. And SpotRF really strives to provide peace of mind. So if you know you have your product, you know you're getting the best cutting edge technology on the best compact surveillance radar on the market here. And to get you guys all excited about the product here, I got this little video.
Coronavirus has oil below $50 a barrel.
Europeans and Americans are considered expenses.
So it's just a quick little promotional video to get you guys excited to sell Spotter F. Really quickly here, we're just going to go through a little bit of history of Spotter F. It was originally created in on September 2nd, 2009, and it was born out of a commitment from its initial founders and employees to be able to set the tone for what it now is. It was created by a couple, Gloria and Logan Harris. And Logan is actually an ex-military radio engineer, and so he learned that there is a need for in the security market to be able to track something, track in areas greater than 5 acres but less than 300, because we found that there's lots of long-range radars and very few small range, but there's very limited number covering this small field, small area. So the first radar that he produced was a military-based radar, and he was able to track 500-meter area with it. And I can show you guys how we can still do that today. We can grab the radar data and export it into a simple GIS interface like Google Earth, and have a really neat overlay of what it all looks like. So all that is still in the original, is in the radars today, these original features. In 2010, we got our first major government order, and that led on to a lot more R&D. And in end of 2011, we produced our first commercial radar, the C40, which I'll go over in a little bit here about the range and all the other C units that we've produced or manufactured today. And you can see here on the right, the C40 is about the size of a novel. And I got more dimensions on it in a minute here, but you know, we have this tiny compact surveillance radar, and we mean compact. I don't know if you guys have seen the product, but it is, yeah, the size of a novel. We have a continuous scan rate, and so we're able to see, we're doing 8 scans a second. So, you know, that's 8 frames per second in a camera, but we're able to track over 10 objects per radar on our smaller ones and 20 and 30 on our larger radars. And the if you want to put us on the solar panel, you can see we even use less power than an incandescent bulb. So we're very power efficient. We have lots of capability. At the end of 2012, Spotter F was producing 3 radars, 2 for the military and 1 for commercial radars. And then in 2013 and 2014, with the government work really slowing down, Spotter F focused mostly on the electrical utilities and oil and gas markets with great success. And since 2014, we've expanded our radar base from being 2 military and 1 commercial, or 3 radars, to now we're selling over 30 different radars alone in the military and commercial markets. Obviously, with you guys, we're just going to be talking about our commercial markets because the military ones are strictly locked into the U.S. military, sadly. So Spotter F today. Spotter F today, we are selling our product in over 38 countries. And we've had over 2,000 successful deployments in all sorts of verticals. And just to list a few, we have been very successful in our critical infrastructure vertical, the border protection, airports. As you saw in the video, those airplanes are giant parking lots now. You can drop us in just to watch where the planes are being parked, and we're going to cover that entire area with 1 radar. So you can imagine how much more efficient it would be for my product to cover that whole parking lot, rather than hiring guards to walk around it all day. And then dams and bridges, we found out last year that we work very well over water. So dams and bridges, you want to watch your inlets and outlets, deploy us over water. Same technology as what we use for over ground. It works great for detecting anything. So here's a couple of awards that Spotter F has won over the year. And in the right here, you can see Logan and Gloria Harris. Those are the old Gloria was the president and Logan was the CEO, and Logan has had to step back in as interim CEO for a little while here. Gloria is still with Logan, but she's not working for Spotter F at this time. So really quickly, I just want to give you guys a little idea of how Spotter F radar works. If anybody's not familiar with radar, you normally think of the giant spinning device on like a submarine or on a fishing boat, and it's sending a pulse out and it's listening for a signal back. So what those do is they'll send the pulse and then it listens. Our radars are continuously doing this. They're sending out a pulse 8 times a second, and it's listening for the energy that it's transmitting out to bounce back, because we're transmitting at a very certain frequencies. So we're getting bounce backs on these very certain frequencies. And based on what we can place on a GIS interface where the radar is and where it's facing. And so now we're able, and with that data, we're transmitting energy, listening, and we're able to detect things of any target within the radar's field of view. And the data we collect from that is the speed of the target, the displacement, how far it's traveled, the size of it, the heading of it, and of course the latitude and longitude of the target. And I'm going to show you guys in a little bit here about how we display that on our GIS or mapping interface. All of this is always relative to radar, because we need to put in a GPS coordinates and a heading in the radar. Here's a quick little test for you guys. I don't know how familiar you are with the YouTube page, but here's a little video I want you guys to, so you can see the comparison against SpotRF radar and compact optical PTZ. So you guys see any motion, anybody moving? I know I won't hear you guys talking about it, but you gotta look really close. Anything? I still don't remember where it is. This gets me.
Nope, we don't see anything.
No? Okay, there's something there. You should see it in the next frame. See the circle around the target?
Yeah.
That guy was walking in the field of view the entire time. So there's the target. Couldn't see that with your eye. And imagine in windy or hard to see weather conditions, right? That target could walk up that close to you. There's the risk. And there's the right there, the value of SpotRF. And in this instance, we were tied to a high definition camera, so you'd be able to see where the target was. All right, so there's a quick little one just for you guys to see, you know, the benefit of SpotRF versus the regular PTZ. Not that the Bosch MIC wouldn't be able to do that itself with the new AI learning and classification, because it's such a nice camera. But anyway, so that's about how the SpotRF product works, and you saw and a little bit of history about it. So now we're going to go dive right into our SpotRF products. I'm going to show you guys what you actually came here to see. So what I have first here is the CK series radars. What you need to know about the CK series radars is these run in what's called the unlicensed frequency band, or the K-band radars. So Industry Canada, who monitors and maintains all of the frequency bands in Canada, has left, and it's pretty standard across the world, to have the small frequency band in the 24 gigahertz range that is unlicensed. You don't need to let them know when you're installing anything at these frequency bands in Canada. So you can put these up anywhere, but you will find that there's other devices using this frequency band in Canada because it's unlicensed. You have to pay to license it anywhere. So because of that, we have smaller range radars in this. And remember how in the beginning I told you these radars are as big as a book? So there's the size of the unit. It's 9 inches by 6.9 inches. That's the housing. It's a polycarbonate housing, and they're IP66 rated, which I'll show you in a second here. But the crazy thing is, from this little unit, 6.9 inches by 9 inches tall, we can cover a new range of 450 by 350 meters, or 28 acres, from one small unit. It's crazy how much area we can cover. This looks like a wireless access point, if you know, like you would sell a Ubiquiti one. And the neat thing is, in the last year and a half since I started with Spotter F, we have released the CK40, the CK20, and the CK5. So if you'd heard of Spotter F previously, you would have only heard of our CK2 and our CK10 series. The R&D that we're doing to grow and expand our product line is amazing because everything is being done in-house in Orem, Utah. It's amazing. Every week we get new updates on the new hardware that's coming out, the testing that's coming out, the energy that's being coming out. So it's just fabulous. So yeah, it's crazy. We used to only cover 4 acres with the CK series. Now we're covering 28, 7 times the area. Just amazing. But with the CK series, these are our smaller range ones. Just wait until this next slide here. Oh, sorry, not this slide, the following one. What you saw in those green field of views, this size range here, the 250 by 175 on the CK20 and all these sizes, that's to detect a human. When we go over here, you can see for our walkers, that's our detection range. For vehicles, we actually have a much larger detection range. So with the CK40, we can track it out to 600 meters away from the unit. This is absolutely amazing. The other important thing to see here is we can track 10 tracks, and you're gonna see what a track is in a few minutes here when we jump over to the live demo. 10 live tracks at once the radar will detect on the smaller units, and then on the larger units we're going to detect 20 targets a second at any time. So that's amazing. We're able to track that much data and classify it, and I'm going to go into a lot more features of everything that we can do with this. Like I said earlier, this is in the frequency band. It's the unlicensed frequency band. And the really neat thing is these units are all IP66 rated. They're good down to -30 for startup. I've seen these things. We have some running up in the Arctic Circle, and you're going to get another little video at the end here of a really cool installation we have with these CK units, and they work fine at -60 once they're up and running. So the temperature range is just for startup. Storage, it's good down to -60 and up to plus 100, and same with storage. So polycarbonate housing, and that's the CK series. So the C series, this is really where, remember earlier I told you guys we had the C40 was the first commercially available unit. It's still here in production because it's such an amazing unit. Previously I said we were covering 28 acres with the small form factor. So you can see this top radar here is the 9" by 6.9. These C20, 40, and 40 EXT, 50 acres from that same small housing unit. It's just amazing. That's why we're the best compact surveillance product on the market. We can cover 50 acres from this little thing, the size of a book. If you need a larger area covered, we have larger radars available for you. They get a little bit heavier and they draw a little bit more power. And the reason why we had to put a bigger housing is because you have to actually separate the antennas within the radar housing. Otherwise, you're getting too much feedback. So as the radars get bigger, we're putting out more power, farther apart the antenna from the receiver, and we're able to cover a larger area. So 300 acres, weighs less than 5 pounds. Just amazing. And then really quickly here, you saw those values previously. Like I said, the values we display on the data sheet are for walkers, but you can see we can track a vehicle 2 kilometers away from the radar. Just amazing what we can do with this stuff. And as you can see down here, the larger units have more processing power, so we can track 30 targets a second with the larger units, which is just amazing. And we have 2 units of the C1050B, one that's rated down to turn on at -40, which is amazing. And then we also have a high temperature unit, just a little different welding and insulation on the housing for that. The big thing with these C series is that they are licensed in Canada. So if you are deploying them in Canada, you need to let Industry Canada know when they're being deployed and where they're being deployed. They need a GPS coordinates of the site, and it costs the end customer about $30 a year to maintain that license. And it just lets them know that there's something broadcasting in this frequency band at this location. If you are looking at doing a C series install where you need the larger area, we do what's called a site survey, where I would come out to site with a C-series and we would scan the area with the radar and see if there's anything else running in that frequency band. Because if there is, it will jam up and saturate my frequency or the radar with its signal, so we wouldn't work with that radar. So we'd have to either look at changing the channel. So we can change the channel from like 10.0 gigahertz to 10.1 to 10.2, and we can offset that channel so we'd have a better detection, and we wouldn't be getting saturation from the other device if there was one. So that's the C-series radar and our ground detection radars. Now I'm going to jump over to our counter drone radars. We have our A-series radars, and these are stationary. They're placed on the ground, and you point them up at 10, 25, 30, or 45 degrees, and now they're watching a slice in space above you. So these are almost identical to the C-series radars, but we have to put a special firmware in them to detect altitude as well as GPS coordinates. So these radars are pointed up in space, and you can see here we can cover 200 meters of space all the way up to 1,000 meters in a slice of space here. I use the term slice of space because this next slide I'll show you. You can imagine the radar. We had previously been looking this is the top view of the radar. This is the side view of the radar. So it's literally just a slice of space. But if anything flies through that slice of space, we're going to detect it. We're going to let you know that there's something up there. And with these radars, you can see it's still the 9 by 6.9 inches, or for the smaller one, and then for the larger one, we have a larger unit. And you can see here we support the different angles that it'd be pointed at. So if you have an area, you just want to point some radars up, and you would be notified if anything flies in your airspace above your building. For example, we'd let you know. We've even had one install where we have these units pointed straight up, and they're detecting anything that flies above a building. So they're literally installed on street lights pointing up, covering a government building. But I didn't tell you guys that. And then this is my favorite unit, the 3D series. This is the same kind of idea, mounted on the ground, but it's covering airspace. The big thing with this is it's no longer a slice of space. We put a radar on a motor and we're spinning it. So now we're able to track latitude, longitude, and altitude and create a complete dome of coverage over wherever this unit is installed. So my favorite unit is what I'm going to say. But here it is. This is the motor, and then this is the 3D 250 or the 2D 250. We sell it in two different programmings, the 2D unit and the 3D unit. The 2D unit does not track altitude. It just gives you a field of view and lets you know where the target is. The 3D unit will track it in altitude. This is a special housing and motor that we're having manufactured for ourselves, or for SpotRF. And this unit is good down to IP66 rated, so it's good down to -30. These units can track up to 20 targets in the air at once while it's within the field of view. And I can't say enough about this unit. I love it. It performs awesome. If you want to see a demo of it, I don't think I actually have a demo of that today, but I can definitely schedule one and get a drone to fly around for you guys, and you'll be able to see how it tracks, and then we could do a whole bunch of neat things when we see a drone in the air. So that's the radars. But now, what do we do with all that radar data? Because all it's doing is, like you saw earlier, listening on a frequency band, and then it's sending all that data to something. So that thing that we send the data to is the SpotRF networked IO. The networked IO is a web-based server. So we put this unit somewhere on your network, and then you assign an IP to it, and then you just access it through your Chrome browser. So with the networked IO, we're able to process all this raw JSON data, and JSON is a type of API format that we use. And that's received by the networked IO, and it displays it nicely on a mapping interface. So you saw earlier we had the C40. So this is a C40 EXT, I believe. So you can see there's where the radar is, here's the field of view, and we can draw zones in that area. So when the track data comes in, it displays it nicely so you guys can see the track data And then the real power where the networked I/O comes in is we're able actually to slew to queue PTZ cameras to follow the targets of anything we identify as either hostile, or if we want to follow humans or vehicles or animals. We can do all that from the networked I/O. We can trigger alarms into a VMS. So with Novytec, we set up a milestone system with them. So we're able to send alerts to milestone, for example. If you want to be sent email alerts when you get a target after hours or a health alert on the radar, we can send email alerts right from the networked I/O. And last year we came out with our Spotter RF AI. And I'll go into that a little bit more, but now we're able to classify the targets based on the data we're receiving back from the radar. We're able to say, oh, a human couldn't travel, 30 kilometers in 2 seconds. So it's obviously not human. It could be a large vehicle. It could be a whole bunch of things. So we have started classifying it, and we're only doing that at the networked I/O, not at the radar. So that's the networked I/O. We have a couple different form factors of our networked I/O. So we have recently retired our old CC8 line, and we are now replacing it with the Neo DIN. The Neo DIN is a lot more powerful. It's got a Intel i5 core processor, and we are selling it in, it's IP66 rated. It mounts on DIN rail, good down to -40. We sell it with the power supply. It's got different sizes of hard drives, so you can store data into it longer. Just amazing is the Neo DIN, which is brand new, just released October 1st for resale. If you have some sites where you need to do a mobile solution or mobile deployment, like what you saw in that video, we have our Hub 4. That's the IP67 rated networked I/O server. You can take that out in the field. You can power it off a battery. You can power it off your vehicle, and you can do testing. You can do temporary management, area management. We have a couple customers that our units are attached to a milk truck. They drive out, they park the milk truck, it's on battery backup or a solar panel, and they run our system off of it with this networked I/O server. The other one here is our Neo APL. This is our rack mount 1U server. Now, what we learned is this unit used to be called the Neo server, but anytime you tell a customer you're putting a server in, the IT department goes nuts. So now we're calling it the Neo APL or appliance. So we're kind of getting around that. Another thing we support is we actually can produce virtual machines. If you want to take care of the redundancy and you can provide a host, or your customer can provide a host, we're able to provide the VM image of the site for them. And we support manufacturing the VMware, Hyper-V, and VirtualBox VMs for them. So if you place the order and you say you want a VM, we can do them in various sizes. So we have different pricing for how many units you can attach to it. And then lastly, the hosted Neo. And I'm going to show you guys what that looks like. We have created an AWS cloud-based networked I/O solution. So we've taken our VM and we're hosting it now on the AWS cloud. So we would, if you were interested in that system, we would ship you a router as a part of your loan agreement to have it. And then we would take care of all the data. We do the upload and the download speeds that would come up to the AWS cloud. And if you're interested, we could even put cameras onto that modem so that you're able to see your camera and the radar from the cloud anywhere in the world. So cool. So with the networked I/O, we're able to slew to queue PTZs. Well, what PTZs? So all of the camera drivers for PTZs are built in-house, and you can support the Bosch MIC, which is the best integration that we have. Just saying. But we also support more than Bosch. We support Axis PTZs, Vision 360, Avigilon, Canon, FLIR, Hanwha. If you have a PTZ and you can pay us and ship the camera to us. We will build the driver for you in 2 weeks, test it, and give you the camera back with a working copy of the driver. So you're now able to bring in whatever camera you like. We can work with it. We'll drive it. We'll control the zoom, and I'll show you in a minute here on the live demo how cool it is. like I mentioned earlier, we do VMS integration. So we are working on a Bosch VMS integration right now here, and we should have it turned around in under 2 weeks. We have it fell on the wayside, but after talking with Matthew, he gave us some really good insight about how to get the SDK and the integration done. It's really, really easy, and so we'll have that out. We maintain any versions on it. We have copies of the VMSs at our office to do testing on. But we have done direct integrations into the Axis, the camera station, the FLIR Latitude, the Milestone VMS. We actually won a MIP award for. I think it was in 2016. I'd have to look. It was in the awards that we paid attention to. But Avigilon Control Center, Genetec built their own RSA plugin that we work with. We built our own for Honeywell ProWatch and ExactVision. There's a whole bunch more of these available. I just listed a few just to let you know. So we can do that for free, except for the RSA and the Milestone built into our system. You don't have to pay anything extra. But we'd like if you would pay for the, the extras. The network spotter RF AI machine learning. So what this next slide is I told you guys that we can do auto classification. So this is where you can see in the page here. We have various targets in the radar's field of view. The networked IO is taking this information. I told you we were grabbing latitude, longitude. The average speed is calculated in the NEO. There's the displacement, the duration it's been in the field of view, and the average size or radial cross section. Based on all that information, the system is now classifying, saying there's a primary AI classification of 95% that it's an animal and 2% that it's a human based on what it's seen. And you can see down here on the left, we have a bunch of different classifications that we can see. The system is doing this automatically for you out of the box. What you have to do is the machine learning. Because radar field of views change wherever you point them, and there's different interference and static, you need to do some AI machine learning on the device. And I can show you guys how we do that, and it's very simple in a few minutes here. So with all of our deployments that we saw across the world, we needed a federated product so that we could do management of multiple sites. SpotterF introduced the SpotterF COP product. So COP meaning Common Operating Platform. And so now we are able to manage multiple sites from one web interface. It's still web-based, so you still only have to throw a server into your environment, assign an IP to it, and now we're monitoring it. And we can, from this COP, we attach various sites into the COP, and you can see here, there's all of the ones attached to this one COP across the world. I'm going to show you guys this one in a minute here. Or sorry, not the world, North America. We have various other ones in other countries, not in North America. But there's all the sites. You can see here we have alerts. So those are alerts coming into those sites. So now your customer can dial in and they can see, oh, there's an alert on this site. I better click on it and see. You can manage all of the other networked IO sites from this one interface if you have multiple. And you get this for free if you purchase our SLA program. So another real neat thing here is SpotterF is more than just securing areas and protecting assets. Like I said in the beginning, we're about saving lives as well. So a couple of years ago, we partnered with Polar Bears International, and we're also detecting animals. So I'll just give you this quick little video. So that was pretty neat, and we've actually been approached by other wildlife conservation companies to help them monitor animals, because it's so, you can think with a an optical, a thermal camera, you can track it if you can see it, but in harsh weather conditions up in the Arctic Circle and the Antarctic, you get harsh weather conditions. If you can get us power, we can put our product up and we can monitor an area for you. This little town north of Churchill, they were having deaths. There were polar bears coming in and eating people. So the Spotter F is the pre-alert system. So when we detect only animals, the system will alert the community to go in and secure themselves, because there's polar bears, there's wolves wandering around the area and they're hungry. So that's pretty neat how, we're not just about, protecting critical infrastructure. We're all about saving lives. We have a really nice community involvement with them, and we're looking at expanding that. So that's my presentation for you guys real quick. I hope it wasn't too boring. I hope those videos kind of give you an idea about Spotter F. So now I'm just going to move over to my other screen here. Sorry guys, we'll move. We're gonna probably see me again, right? Okay, so what you can see here, this is that Spotter F cop that you guys had a quick little screenshot of earlier. And if we zoom out, there's a whole bunch all over the world. So from this one interface, we can monitor all of these sites. All of these sites are individual NEOs. Click on the site. It's going to take you to it. This is all on the AWS cloud, all web-based. So all of the data for all these is being shot up into the cloud. And here is the live demo system. So this site is in Orem, Utah. Here is Spotter F's headquarters right here. And then you have a C40 EXT right here covering this area. And this is a particularly busy morning. As you can see, we have a whole bunch of people walking around. And as the system is seeing them when they're walking around, so the radar seeing actually 4 people, isn't seeing 4 people, but it's grouped them together. So because there's such a big size of the target that it's seeing, it says it's a vehicle small. 51%. Oh, now it reclassified them as a person at 56%. So that's where you do our classifications on the system, and then that'll allow you to have better targets on it. So we're picked up the target, and now we're following with the PTZ. We could be sending an alert to the VMS or an email to the customer saying there's people in your area. And the nice thing is with the emails, if the camera's set up, we're also going to send you screenshots of it. We're going to send you all the data about it, like the lat along the time is going to be in the email. You can draw zones into the space. So you can see how in the middle here it's flashing red. So we can do all that right from the one system. And then let's see here. So we'll turn off the preview, and we can see we have all of these all the data here. We can click on the track and we can see it. Once again, here we can see the latitude, the longitude. The track dropped, it went black. So we'll click on a new track. And we can do our classification. Did we see that this is a person? Let's see this track, this blue track. Okay, oh, the camera went off a bit, but I want to see it. Let's just click right on the screen. I just drove the camera right to follow those people. Pretty easy, eh? So we confirmed that this is a person walking right here. So we're going to confirm that was in fact a person. It sets the probability of it being a person to 100%. Once you've done a few tracks of that, we go over to our AI and you would hit run training. You can see down here that we have 65 trained tracks on this system, and we have 66 ready for training. So of those trained tracks, 30 of them were birds, 7 were people, 22 were medium vehicle, and 7 were small vehicle. So the radar or the AI system takes all this data and learns it and applies it to probabilities. So now we're able to see, oh, this target, you can see here it's 52% a person. Let's go on the map here and let's click on it. Turn our little preview window back on. Oh, our targets are way out there. You can see this is 100, 200, 300 meters away. We're tracking a target here. It's a little hard for the camera to see, but the radar has no problem tracking it. That small vehicle was that. So that was the small vehicle here. It said it was a small vehicle, but we're going to confirm it as a person. Pretty easy to do all our AI learning. And that was about the end of my presentation. Do you guys have any questions? We can turn off the mute and you guys let me know. I have about 15 minutes here.
Just a comment. You would have had a better view of that person far away if it was a Bosch MIC camera, right?
I'm doing my best to upsell you guys.
Totally agree with that.
Okay,
Oh,
can
yeah.
you explain why the MIC camera in particular is better as an integration with spotter from objects that are further away so that they can understand?
Well, like with the MIX 7000 or the 7100, the zoom lens is just way better. We actually write a custom driver for each MIC because you have so much capabilities with it. Like the zoom control, we've finely tuned. We've had way more time and way more opportunities with the MIC, so we've had a lot more time to make sure that it's a really good driver. We are sending absolute data to the MIC and it's able to respond to that. And with the new 7100, we're actually grabbing the classification data out of that unit and we're putting it into our probability. So we'd grab the classification, we'd say, oh, the MIC says it's this much probability of a human, and we're going to add it into ours. Now we have an awesome probability of seeing what our objects are. And 1000 with the dual thermal and optical lens, we're able to point that up in the air and we're able to track drones with it, because tracking a drone in a clouded area, you're not going to be able to see that with the regular optical lens. So we're highly recommending the MIC 9000 with the thermal for tracking drones in the air because it sees above horizon, which not as many PTZ cameras do. They normally limit themselves at only seeing about 10 degrees above horizon. The MIC does it lovely. I can't say enough good things about it. The MIC 9000, the MIC 7100, and the MIC 7000, they perform fabulously. We can send signals to them to fire the infrared or the LED attachments onto the units. We've never had an issue with it. If we can deploy the MIC there, we can deploy spotter there. If we can deploy spotter there, we can deploy the MIC there. It's hardened, it's solid. We've never had any issues with it.
Good sales pitch.
It's such a
Ryan?
great camera. If you haven't played with one, you need to.
Overall, it seems like a pretty nice little product line. I just had a question in regards to the 2D, 3D models, because I guess if in the case of it creating sort of a dome, pick up ground and air targets, or is it more still for just air targets?
It's designed for air. You will pick up some ground targets because of the way that the field of view of the radar. So if you imagine it's a radar with a 90-degree field of view, right? Here, let me. So this is a radar housing. I think you guys can see my camera or myself. So there's a 90-degree field of view out of the unit. Sorry, we'll do it like that. So 90-degree field of view out of the unit. So what we did with the 3D unit is we pitched it at 45 degrees. And so now you have your ground 90 degrees and your up 90 degrees to give you a complete dome. So if you're mounted low on the ground, like on ground level, you will pick up targets. It is designed for air targets. So if you want to do ground targets, we're saying go with the ground series. If you want drone detection, counter UAS, air detection, even airplanes, we will detect it with, we would recommend it for that. We are finding out that the biggest issue with it being mounted on ground level is so many things interfere with the radar signal, like the pavement, like the trees, like the grass. They cause interference on it, so we're not able to better track in the air. So the higher the install, the better for the counter UAS drone detection. You know, like on top of a building is really good, and just like on a mount that's 6 feet above, so you clear the parapet, that's really the best environment for the 3D, 2D 500.
Okay. So would you be able to combine, obviously different RF spotters for both applications then? Is that?
Oh, absolutely. Yeah, so this networked I/O you see here, this unit could be managing 3D 500 radars, the A series radars, and CK series radars, all from this one web interface. The networked I/O is the exact same. Adding a radar is just another input device into the system that we're able to manage all the radars with. You have to connect the networked I/O to the radar, or the radar to the networked I/O, to get all of this mapping interface. If we went into the individual radar, that's where you can look at tweaking the energy output and very few things you would actually do on that individual antenna or radar. Everything and all of the good stuff, the AI classification, is all done in the networked I/O.
Perfect, thanks.
But yeah, you could put the 3D 500 and then you'd have a mount, clamped radar mounted to the base of it. It all comes into the one interface. If you want to have a single mounting point, we can work with that too. We have sold solar panel trailers with the 3D 500 unit on it, on a mast that goes up, and then we had 3 radars at 3 C20s covering a 360-degree field of view on the ground. And the 3D 500 draws, I think it's 5 watts of power when it's up and spinning. The smaller radars also draw 5 watts of power, and then the motor on that draws, I think it's 24 or 48 watts of power. So we can power our entire system off of a mobile trailer and solar panel, no problem. Okay. Anybody else got any questions? I hope you guys enjoyed it, and thank you very much for attending.
All right. So thank you, everyone. Don't forget, okay, there is no webinar next week. Okay, so we're going to see each other, okay, in 2 weeks for the